Continuing where we left off, I'm going to be building out the loan proceeds, interest only and amortizing debt service, and our balloon payment. Starting with the loan proceeds, I take the total cost acquisition and multiply it by our loan to cost, which is 70%. Debt service is a lot trickier. There's the initial term of the loan with the remainder of the loan term then amortizing. So starting off, I want to only calculate debt service during our debt term. Next, I'm building out the interest-only payments, which I ensure only take place during the interest-only period. In this case, that's 2 years multiplied by 12, so the first 24 months. And our interest is simply our loan proceeds multiplied by our monthly interest rate. The second section of the equation is for our amortizing debt service, or in the current case, that's past month 24. So as you can see here, our debt service increases in month 25 when our interest-only period rolls off. Balloon payment can also be a little bit tricky. At the core, we're looking to find the present value of the loan after a certain period of amortization. Using the present value formula, the interest rate is converted into a monthly rate, and then I calculate the number of periods that the loan has amortized, in this case, 5 years. And then I use the payment formula to calculate the amortizing payment. And using a similar strategy as with debt service, I'll make sure that the balloon payment only occurs in the final period. So as you can see here, our debt service and balloon payment end in year 5, which is exactly what I'm looking for. Levered cash flows are the sum of the unlevered cash flows as well as the debt cash flows, which I just calculated. Levered IRR, I can take the same formula and adjust the unlevered cash flows and change them to my levered cash flows. Use the same strategy for whole dollar profit. And for our levered equity multiple. Then I format accordingly. The case asks for a sensitivity analysis of levered IRR as well as whole dollar profit. So I'll build out those first two tables, sensitizing hold period and exit multiple. I use a spread between 11 and 13 for exit multiple, and then a spread between 3 and 7 years for the hold period. format as percents, and format the IRR input as a blank to make it more visually appealing. I copy my levered IRR table and use it as a base for the whole dollar profit sensitivity analysis. And I need to just change the percentages into numbers. And this is the beauty of data tables. Changing my exit multiple to 11 and hold period to 3, we see that our returns are the same exact returns as calculated in our sensitivity table. And this all works because our model is dynamic, right? Our debt term is based off of our hold period, and everything works together smoothly for Excel to make those calculations. Before I continue, I want to fix our balloon payment formula. So the formula currently calculates the amortization period as if there wasn't the 2-year IO period. So to fix that, I add the IO period so that the loan amortizes over 3 years. And as you can see, the balloon payment increases as we're amortizing over a shorter period. In any case, back to our regularly scheduled programming, I'm going to copy the previous data tables and change the columns to be price per key for our second set of sensitivity analysis. Then copying the structure for whole dollar profit. I do the same thing for interest rate and loan to cost sensitivity. Now I'm going to format everything, edit the names of the tables, just to make sure my tables are visually appealing. And here you have it. This is how I would build out the Stillwater case. We have levered and unlevered cash flows, as well as sensitivity analysis for exit multiple, hold period, acquisition price, loan to cost, and interest rate. Now you may wonder why the tables don't look the same. And that's because I changed some of the initial parameters. If I revert hold period back to 5 years and the exit multiple to 12, you can see that all the tables reflect the same initial metrics. I hope you enjoyed the video. I definitely enjoyed solving this one.